Hello everyone. Today let's solve the problem number 74. Search a 2D matrix, right? So here what the question states here. So we are given a 2D matrix of size m into n. You can clearly see here. Let's come to the first example part here. So we are given a 2D matrix of size m into n. Nothing but m is nothing but rows and n is nothing but the columns here, right? So we are given a 2D matrix of size m into n. M is nothing but the row and n is nothing but the column. So here each row is sorted left to right. Each row is sorted left to right, and the first element of each row is greater than the last element of the previous row. First element of the each this one first element of the each row is greater than the last element of the this one previous row, right? I hope this part is clear. Each row is sorted left to right, and the first element of each row is greater than the last element of the previous row, right? So this one they are speaking. So first element, this one 10 is greater than quite obviously 7, and 23 is greater than 20. So don't get confused here. So we are given an integer target. So here target this one. We are given an integer target. In this case, we have been given 3, right? So we have been given an integer target 3 here in this case for the example 1. We are given an integer target. We have to return true if it is present in the matrix. So by looking at it, we can tell here. So 3 is present here. Our main task is to check whether 3 is present in the matrix or not. And if it is present, then we have to return true. If it is not present, then we have to return false. We are given an integer target, return true if it is present in the matrix, else return false. So we must solve this one, and big O of they have clearly mentioned that in the question we have to solve this one within big O of logarithmic m into n time complexity. N time they have given means the time complexity has to be within big of logarithmic m into n, right? So we are given an integer target. We have to return true if it is present in the matrix, else return false. We must solve this one in big of logarithmic m into n time. So that's what they have given in the question. I hope the question part is completely clear, man. Very easy to understand, right? Same goes with the second one. Same goes with the second one as well. There is no difference at all. So I can just look into the second example in the same way. So let's do one thing. Let's discuss the approach first. Let's discuss the approach followed by the complexities, and then let's write the code, right? So first, initially, let's discuss the approach here. So here, first example, let's consider the same first example so that it will be easier for us to solve the problem or understand the problem basically, right? So here we have been given target 3. This is the matrix 1 3 5 7 10 11 16 20 23 30 34 60, right? So here what we'll do, we will treat this entire matrix as a flattened sorted 1D array, right? So flattened means here in this case, this one will not be considering array. First, initially, we'll be considering this one 1D array. Uh, will not consider this one nested arrays, right? So so here in this case we'll be considering only single 1D flattened sorted 1D array of size m into n into 3 into size m into n means 3 into 4. Here in this case we have 3 rows and 4 columns, right? Size 3 into 4 here, m into n means 3 into 4 here in this case, right? So here we have to treat this entire matrix as a flattened sorted 1D array of size m into n, nothing but 3 into 4, nothing but here 12. The value we got here is 12, right? 12, 3 into 4 is nothing but the 12. So we will be applying the binary search on this 1D range. So here we are just flattening the array. So this one is already sorted. You can clearly see here 1 3 5 7 10 11 16 20 23 30 34 60. We can perform binary search only when the array is sorted, right? Here in this case we had the 2D matrix, so we converted that one to the this one array, basically sorted 1D array, flattened sorted 1D array of size m into n basically, right? So here in this case we get the value within the array. We get 1 3 5 7 10 11 16 20 23 30 34 60. So now we don't have the nested this one arrays, right? So instead of the matrix we are displaying this one in the array. We have successfully converted to array. Now we apply the binary search on this 1D range. So initially low will be 1, so the first element, so this one initially low will be at the first index or the 0th index, nothing but 0 means index we are speaking of, we are not considering the value. And high will be here on this case, high will be this one 60. So here we have 3 into 4 matrix, nothing but 12, right? So this will be length minus 1, length minus 1, array length minus 1, nothing but what matrix dot length minus 1 it will be, right? Or m into n minus 1. So this will be 12 minus 1, here in this case it will be 11, it will be 11. So here high we are assigning this one to 11, right? So we'll find the mid 0 plus 11 by 2, so we'll get something 5 point something. So we need to go with the this one whole number, so let's go with the 5 here. Mid equals 5, value of the value at the 5, the value at the index 5, this is index starts from 0, this is 0 comma 0, right? 0 comma 0, 0 comma 1. So let's consider here 0 comma 1, 0 comma 2, 0 comma 3, 1 comma 1, 1 comma 2. So this one 1 comma 0, 1 comma 1, so this one is the fifth one, right? 0 1 2 3 4 5. When we convert this one to the this one, what do we call 1D array, so this one will be the fifth element. So fifth index, the element present in the fifth index, so this one will be 6, this one will be 7, this one will be 8 9 10, and this one will be 11. Basically fifth index, what element is present in the fifth index? 11, right? So now we have found the 11. So basically what happens, 11 is too big, 11 is too big, we have to find the element 3 which is present at the first index. 11 is too big, 11 is too big, so we'll carry on with the next steps, we'll carry on with the future steps. So let's carry on with the, or let's move on with the further steps here, right? So next we will move the left. When we move the left, mid will be 2. When we move the left, mid will be 2. 2 means the value that is present at the second index will be 5. The value that is present in the second index will be 5. This is also still high, this is also 5 is uh, higher than 3, 5 is greater than 3. So basically again what we'll do, we'll move the left to mid. Again we'll move the left to mid. Here we have previously we have moved the left to mid, now the value we got is 5. Now we'll again move the left to mid, now the value will be 1, the value will be 1, and this is low, 1 is less than 3 and this is low basically, right? This is low, this one this is fine I think, right? So we have moved left to mid, nothing but this one second index, and this one we are moving into the 0th index, and this is the first index. So here in this case the value is low, 1 is less than 3. So the final we are left with here the mid. So we will move the right to mid, nothing but here now we are moving this one to the first index, and the value that we have got here is 3. The value that we have got here is 3, nothing but the matrix 0 comma 1. In the array this is first index, in the matrix it is 2D matrix, right? It is 0 comma 1. So 0 comma 0, it starts from 0 comma 0, right? So this will be quite obviously 0 comma 1 in this case. So now here when we check, 3 is equal to 3, 3 is equal to 3, right? We are comparing 3 is equal to 3. So now we have successfully found a match. So what we'll do, we will return true. We have found the 3 in the matrix at the index 1. So what we'll do, we will return the by this one boolean value true. So this is how we apply the binary search on this particular problem, right? So by assigning the left and right to mid, basically by assigning the left to mid, sorry, not left and right to mid, by assigning the values to the mid, by assigning the values to the mid, we will check one by one basically, and then if the element is present, if we find the element at particular index, then we will return boolean value true. Else if we have not found, if we have not found the element, then we will return false in that case, right? So I hope this part is clear. Now we are done with the this one approach. Now we are done with the approach part. Let's discuss the complexities quickly. So they have asked us to solve the problem in big of m into logarithmic m into n. So the time complexity would be quite obviously we are solving this one by making use of the binary search with the time complexity of big O of logarithmic m into n. So this will be time complexity. This will be time complexity. And what will be the space complexity here? Big O of 1. So this will be space complexity. So this will be space complexity, and this one will be time complexity for the code that will be writing in the future. So this is time complexity, and this one will be the space complexity here, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be this one. What do we call? Big of logarithmic m into n and big of 1. I hope the this one complexities part is completely clear along with the approach. Now as we are completely familiar with the approach and this one as well as the complexities, we are good to write the code. Let's start writing the code, right? So first thing is we have to initialize the number of rows and number of columns, right? So I'll just go with m equals, as it is 2D matrix, so let's go with matrix dot length here. This is fine. So let me copy the matrix term matrix here. So let me assign n to this one columns, right? So this one will be matrix of 0 dot length. So this is fine. Next part is we'll be starting the index of the 1D flattened matrix, right? So for that one, let's assign the let's initialize low to 0 and high to this one m into n minus 1. This one we saw in the approach, right? So whatever we discussed in the approach exactly we'll be doing, we'll be articulating the same thing in the form of code here, right? So next let's perform the pure binary search here. So this one, let's go with while low less than or equal to high. Then within the while condition, what we'll do, we have to move the middle index in the 1D space. Means here in this case in mid equals low to avoid the overflow, right? So this will be low plus high minus low by 2. This is fine. So the next step is uh, we have to check the row in the 2D matrix, and also we have to check the column in the 2D matrix. We have to check the row and column in the 2D matrix. Means here in this case I can write in this way: int row equals mid by n, and also int column equals mid modulo n. This is fine. So the next step is we have to get the actual matrix element. In this case it would be int mid element, int mid element. This one will be matrix of row and column, matrix of row and column. So we are just getting the actual matrix element here. We are getting the actual matrix element here. So the next step here would be, if we have found the target, then we have to move right, else we have to move left, right? So that's what we did in the approach by considering the first example. If we have found the target, uh, so sorry, if we have found the target, we have to return true, else we have to move right. One more condition, means if the mid element is equal to target, we have to return true. If the mid element is less than target, then we have to go with low equals mid plus 1. Low equals mid plus 1, nothing but we have to move the right pointer here. In this case, if the mid element is greater than the target, then we have to move the right pointer to left. Means high equals mid minus 1. These three conditions, pure binary search again, right? If the target is not found at all, then we have to return false finally. So these are the three conditions, and final one, if the target is not found at all, then we have to return false. These three things we have to articulate in the form of code. Let's do that one quickly. First, if the mid element, if mid element, we find this one at the target, let me copy this one. If mid element equals target, then in that case we have to return the boolean value true, right? So else, if I'll not go with a bracket, so this I'll just write this one directly. This looks neat actually. This is fine. Else if mid element, if it is less than target, then what we have to do, we have to move the uh, we have to move right actually, right? So here this will be mid plus 1, low equals mid plus 1 finally. Else we have to move to left basically. Now we can write in this way: high equals mid minus 1. This is fine. So the final step here is if the target is not found at all, then we have to return false in that case. Then we have to return false in that case. So let me format the code once and let me hit the run button. Let me hit the run button. I hope this works, man. No? Error, cannot find the symbol. We didn't initialize mid element. So here somewhere we mid. Oh yeah, this E has to be capital here. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct. So whatever the code that we have written works absolutely correct, right? So I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.